All right, so today we're learning the tangent ratio. It's the first of 3 trigonometric ratios that we'll be learning over the next 2 days. They all have to do with this acronym. This acronym is what we call SOHCAHTOA, where each letter in the acronym stands for a value in the trig ratio, where you can see that S stands for sine, and then within sine, it's opposite over hypotenuse. That's where the O and the H come from. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that's where the A and H come from. And then tangent, which we're learning today, is opposite over adjacent. And what we're talking about when we say opposite over adjacent or hypotenuse, we're talking about side lengths, side values as they relate to angle measures. You'll see more of what I'm talking about in just a second, but you have to copy down everything that's inside this clipboard along with this acronym. The acronym is the key to unlocking all of these tangent ratios. So make sure you write that down. Okay, so the tangent ratio, guys, here's how it works. Let's say I'm finding tangent A, tangent of angle A on this triangle. You see what I've highlighted, tangent of A? Well, look at where A is on the triangle. So the side opposite to side A, or angle A, would be side A. That's why you see A up here in the numerator. And the adjacent side would be B, so that's why you see B here in the denominator. So it's opposite, the side across from it, not connected to the angle at all, over the adjacent side. You say, well, this side's adjacent to angle A too, isn't it? Yes, but first and foremost, it is the hypotenuse. So the hypotenuse is always the side opposite the right angle. That never changes, okay? The hypotenuse is always the side opposite the right angle. The opposite side is always the side straight across that's not connected. And the adjacent side, honestly, you can do process of elimination. It's not the hypotenuse, not the opposite side. It's the other side that's connected. All right? So that's the kind of the rundown of all of this. And here's how it applies. So for this triangle, PQR, find the tangent of P. So you would say tangent of angle P equals, and now, what was the ratio for tangent? Opposite over adjacent. And for now, guys, I want you to actually physically write this. Eventually, you will have it memorized, but for now, I want you to write it just so you can physically see it. And then which side is opposite to angle P? Very good. Right? Opposite. 77. And then adjacent is what? 36. All right. Now what about, do the same thing now for tangent of angle Q. Which side value now is opposite to angle Q? Which side? 36, right? Opposite. Okay, and which one is adjacent? So now it's just switch, 36 over 77. Who got that right? 36 over 77. Now in example 2, I'm finding the tangent value now of a specific angle. You see here in example 1, we don't have any angle measures. We just have angle labels. In example 2, we're actually going to be given a measure of these angles. Tangent of 18 degrees, 45 degrees, and 75 degrees. First, I want you to check your calculators. And when you turn them on, do you see a boxed in D at the top of your screen? Is there a boxed in D at the top of your screen? Is there a D? If there is not a D, raise your hand. Everybody has a D? Okay, so here's what I'm going to do. I'm going to hit the tangent button that's on the far right side, 2 rows up from the AC button. You see TAN for tangent? hit that button and enter the number 18. Close your parentheses and hit equals. Tangent, hit the tangent button. 18, hit the end parenthesis button and hit equals. What do you get? Very good. Now I want you to go out 5 decimal places. The reason we go out 5 decimal places is because we have to look at this 5th decimal place value so we can round the 4th one accurately. So since there's a 1 in the 5th decimal place, what happens to the 9? It stays the same. So my answer is 0.3249. And remember, I approximate it because I did round to 4 decimal places. I want you to find tangent of 45 and 75 now. All right, guys, so this is very rare for this to happen, but tangent of 45 is what? It's 1. When you hit tangent of 45 and you hit equals, you get 1. That's it. So what about tangent of 75? So hit the tangent button, 75, hit equals, what do you get? Now change it to a decimal. 3.05. So since there's a 5 in the 5th decimal place, what happens to my 0? Okay, so if you don't change it to a 1, your answer is wrong. So if you don't round that 4th decimal place correctly, your answer is wrong, because this is very simply put, guys, just a matter of putting it in our calculator. All right, so all we're doing is calculating a specific value for a tangent of, whatever degree it is. Okay? So you have an entire section like this on your homework tonight. Any questions? Approximating to 4 decimal places. Any questions? All right, in the last example, now we're taking actual triangle dimensions, and we are going to solve for the unknown side length. Let me go ahead and pull that up. Okay, so I want you to go ahead and copy down this triangle. All right, so this right here, this is my clue. I do have a right triangle, so this will work. They have to be right triangles in order for this to work. Go ahead and copy down this information. Okay, so my starting point on these guys is my angle measure. So what is my angle measure here? 63 degrees. So now I have to figure out, how do these side lengths relate to 63? Do I know the hypotenuse? Do I know opposite? Do I know adjacent? Which one of that mix do I know? Adjacent and opposite. So which combination, which trig combination, which I only know one, deals with opposite and adjacent? Tangent. So now that I have identified tangent, I'm going to say tangent of 63. See, tomorrow, guys, when we add on to this and we learn sine and cosine, all of it's going to be mixed together. You're going to be given an angle measure, and you have to figure out, based on the sides, which ones I know, am I finding sine, cosine, or tangent? Today, it's easy because it's tangent for all of them. So tangent of 63 equals what now? Opposite over adjacent. So which side is opposite, x or 10? X over 10. And now you're going to physically solve for tangent 63. So hit tangent button, 63, and hit equals and round to 4 decimal places. All right, so what is tangent of 63? What's it going to be? 1.26 equals x over 10. How do you think you can solve for x? How could you solve for x? Multiply each side by 10. And whatever that number is, you approximate it to the nearest tenth. Your directions on your homework tonight will say, round to the nearest tenth. Find x and round to the nearest tenth. And you get 19.6. So now solve the same. This is just a different triangle, but now I also want you to find the value for x. Find the value for x. Go ahead and set up your equation. Okay, so which one am I finding? Okay, so I know where my angle value is. What side is this? Is it opposite, hypotenuse, adjacent? What is it? It's opposite, and then I also know what? Adjacent. So I know that I'm clearly dealing with tangent. So it's going to be tangent of 38 degrees equals opposite, which is x, over adjacent. What is tangent of 38? 0.781 what? 3. There's an 8 after the 2. Equals x over 8. Multiply both sides by 8. And 8 times 0.7813 equals, and change it to a decimal. Yep, x is actually it's equal to, because I didn't even have to round, equals 6.2504. Did you get that? Did you get that answer? And that's everything you need to know for tangent section 9.7.